Hey everyone, welcome back to another whiteboard chat. And today I have a topic that was actually a request from a while ago. I realized that I never had gotten around to it. I put a question box up at some point, and this was one of the requests I had meant to cover but didn't, so we're going to do it now. And that is covering the fat or lipid digestion process and the basic steps as to how that works. A lot of people know that fat is generally considered a slower digesting macronutrient, especially compared to something like carbohydrate, maybe even compared to something like protein. Now, there's a couple reasons for that. One is the structure of the fats themselves, but two is actually the location in which the fat molecules or lipids or triglycerides are actually broken down. So we're going to talk about that, help you better understand that process a bit. So when we ingest a dietary lipid, fat digestion is going to start in the mouth, just like digestion of other macronutrients. Now, it's not going to be to the extent of something like carbohydrate necessarily, where we have things like salivary amylase and really starting to break these things down. We do have some salivary enzyme production, but it's going to be pretty minimal action on the fats themselves compared to further down the chain. We have chewing, of course, so chewing is going to break things down into smaller digestible pieces, if you will, to help them enter into the stomach and be broken down more efficiently. So the chewing process is still important, we all know that. Once we actually chew and swallow, we'll enter the stomach. Again, there is some enzymatic function in the stomach to help with fat digestion, but it's going to be pretty minimal. Mostly what's happening there is we're having kind of just like physical breakdown of the food itself through the muscles churning through this peristalsis process, and we end up with chyme. Now, this is going to be kind of this gooey type of compound or byproduct that's left over, so we can actually move everything down into the intestinal tract where most of the fat digestion is going to occur. So there's a couple things that happen here. One, and this is a big one, we have emulsification of fats by bile, which is going to be from the liver. There's kind of two prongs to that. One, we have bile production by the liver, and we also have bile storage by the gallbladder. So for those of you that have no gallbladder, or people that work with someone with no gallbladder, keep in mind that these people have less storage capacity, so they often have a harder time with fat digestion. They're kind of just constantly trickling in little bits of bile from the liver or from the bile ducts into the intestines, versus having this extra storage that they can kind of surge this bile salt in with. So those people have to either A, eat lower fat diets, or B, supplement with bile salts. We also have partial hydrolysis by pancreatic lipase, so we have pancreatic enzymes coming in and breaking down these lipid molecules as well. So they're broken down into smaller mono and diglycerides. So we think mono is 1, di is 2. They're broken down into shorter chains or shorter pieces, right? And that is so we can absorb them through the intestinal lining, just like most other nutrients. Now, once they're absorbed, they have to be transported. So they are packaged into something called chylomicrons, okay, for transport by the lymph system. So they're going to be transported to various tissues throughout the body. This could be, adipose. It could be muscle cells, intramuscular triglycerides, right? We have these cells within muscle, around vital organs, in our brain. So they'll be transported all over the body. And there's going to be all kinds of different fats entering the bloodstream too. We know that we ingest a variety of fats. We ingest, omega-3 fatty acids, and there's polyunsaturated fats and monounsaturated fats and saturated fats and all these things, and sometimes trans fats. They're all broken down into smaller pieces or smaller molecules, if you will. However, how they may act once they get in the blood can be a little bit different, because some are more susceptible than others to things like free radical damage, oxidation, glycation, things like that. So they can have various effects to the arterial walls and tissues that they're being either transported through or acting on, or storing in, I guess, if you will. So even though they're all kind of broken down in a similar fashion, or they're all broken down into similar pieces, they can have different actions once they enter the blood and kind of start to do their thing. So that is the short version of fat digestion, the process kind of from top to bottom. So we have a little bit of physical breakdown in the mouth and stomach, as well as some slight enzymatic function there, primarily happening in the intestinal tract with emulsification and pancreatic lipase breaking these things down, making them transportable, if you will. And then absorption, once they're packaged, they can be absorbed and transported through the lymph system, and you get all the nutrients. So I hope that was helpful to someone, and I'll talk to you guys next time.